Hello everyone, and welcome to another tutorial with 3D model for you to download. Today we are going to program this part for water filtration system. So let's start it. To keep things organized, we're going to create new level. Let's call it additional geometry. Now we are going to wireframe tab, and in the curves section select curve all edges, and we are going to create curves on edges around the slot and the top of that spigot. Fit arcs will help us to fit arcs and lines instead of splines, so take that on and select OK. All new geometry is saved in our new level. Okay. Next step, we'll close this arc so we can create a surface on it. So select close arcs, select open broken arc, and selection. There we go. I want to use this part of the arc to create this surface, so I'm going to break this circle on intersection with the slot here, side slot, and I'm going to create now some surfaces. Okay. Escape. So we will start with creating surfaces on this spigot here, slotted spigot. I'm going to create another new level. I'm going to call it, let's say, cap surfaces. To create those caps, we're going to surfaces, flat boundary for the top one, and we're going to select the whole chain. Okay. And to do with the side, I'm going to use a power surface. So that around, and that's it. And you can see straight away that the new surface we just created, top edge is not completely round. It doesn't match the outside shape of our spigot. We'll fix it later. I just want to show you how that surface affects our toolpath. And when we rough the part, I don't want to plunge in any of those holes, so I'm going to fill those holes using option in surfaces called fill holes. Simply click on the face where your hole is, drag the cursor to the edge of the hole and click again. Do the same on the second spigot. Mastercam will create for us surfaces closing the top of the holes. Okay, now it's time to select the machine. In previous videos I was using milling machine. This time I will use lathe, and I will use our Mazak Integrex. Now in the machine group, we're going to use a stock setup to allocate our stock against the job. We're going to use the left spindle stock. We're going to hold the part in the left spindle, click properties, and we are going to use diameter 120 mm by 250 mm long. Okay, all good. Now in my levels manager, I'm going to activate or switch on visibility of cap surfaces level, and we are now ready to program our first operation. Go to milling tab, and we're going to select Rotary toolpath. and we go through basic settings. On the tooling tab, we will select our first tool, and as it is our roughing operation, I'm going to use a big diameter tool, something like 20mm ball end mill. Okay, I'm going to quickly change my feeds and speeds. On the next page, holder page, we are going to select our holder. First, open library, select your holder library, select desired holder. I'm going to use this one, and the projection I'm going to use 50. Oh no, the tool I can select is from 60. Let me just go back. 60mm. Our next page is cut pattern page, and the surfaces, we are going to select the faces that we want to cut. Click the arrow button and then select the top view. You can use the shortcut on your keyboard, Alt and press 1, and then drag the window as on the example here, and selection, cut control. We are going to select the cutting method as a rotary cut. The cam will generate the toolpath around the rotary axis, as you see here on example. The second cutting method is an axial cut. This way Mastercam will generate the toolpath along the part. We will use this cutting method later in this tutorial, so you'll be able to see the difference. Stock to leave box. As this is the roughing operation, I'm going to leave 7mm stock on every drive surface we selected. Our cutting pattern, we are going to select one way, but it is a roughing operation, so you can use a zigzag method and it won't affect our finish on the part. Also on this page you have the standard compensation settings, like a type. You can select to compensate on the computer, on control. You can compensate direction left or right, and you can change the tip compensation to the center or to the tip. I'm going to change the cut tolerance to 0.5 mm. We are leaving 7mm stock, so it will not affect our toolpath. Next one is tool axis control page. First we need to select our rotary axis. You can clearly see that is x-axis, so our rotary axis is also x. You have also 4 axis point that you can select. Basically select any point, and when you tick use center point, the tool will always point the direction to this point. This option is only available when you use a cutting method rotary cut. Even if you use the center of the rotation as your control point, you will still output y-axis motion, y-axis movement. We switch off this option as we want our cuts to be normal to surfaces. Your maximum step over you set here, maximum step. So this is the distance between two passes. We're going to use 7mm for our roughing up. In lead lag angle box, enter the angle to tilt the tool. Lead tilts the tool forward in the direction of the toolpath, and lag tilts the tool backwards. In the axis dampening length box, you can type the value. The greater value will create less angular changes in your two axis control vectors. In the collision control tab, you select your check surfaces, which are surfaces you don't want to touch or hit, you want to avoid. Let's select those, and selection. And in stock to leave box, type in 6mm. Basically this is the distance you want to keep your tool away from your check surfaces. On our linking page, I'm going to change on the feed plane to 10mm. And rest of our options I'm going to leave as default, and let's see our toolpath. As I mentioned at the beginning of the tutorial, path surface might affect your toolpath, and you see the retractions of the tool along the toolpath. So we are now going to fix it. We're going to remove the old surface that we created, and we're going to replace with the new one. And again, I'm going to create the surface using the power surface in surfaces tab, but this time I'm going to turn off the surface that I created on the top of the spigot, so it won't influence or affect the shape of the power surface that we are creating now. As you can see, the top edge of the surface is clean, and to keep things organized, I'm going to move the new surface to level with my cap surfaces. So now, because we recreated that surface, removed the original surface we had, we need to go to our Rotary toolpath and add the new surface to our machine surfaces. Just simply add it on and selection. Okay, let's hit the OK button and see our new toolpath. Wow, the toolpath looks a lot better. There is no retractions or dodgy moves. All looks cleaner. So you can see how quality of the surface can affect your toolpath. So this toolpath is using the rotary cuts. I want to show you also the same toolpath with the axial cuts. But before we do that, I need to finish this back face, as I don't want the tool to hit the wall with every pass in our rotary toolpath. So let's finish this face, and then I want to show you the axial cuts. Okay, so our next toolpath that we are going to use is in milling pattern, and we are going to use a Swarf milling. Don't use the Swarf in the application section, use the Swarf milling in the pattern section. In our case, I want to use this one. Okay, now in the tool setting page, we're going to select the tool. So the tool I need is, let's check, going to home, dynamic, and let's check the radius. You can see here is 2 mil. Okay, press escape to go back to window. So I want to use bull nose cutter. Let's say I'm going to use these are bull end mill cutters. So I'm going to filter, and this is the end mill bull. Double click left button and it will select only this section. Let's say there's 2 mil corner radius. Let's select this one. Of course, you can put your feeding speeds. And the next page, we are going to select our holder. Going to use a different library, and I want to use this one. Okay, and I'm going to select this holder. And projection box, I want my tool to stick out, let's say 60 mil. In the cut pattern setting page, we have the geometry selection, and you need to select your cut-in surfaces, the surfaces, the faces you want to cut, and one of those 3. So I'll show you all 3 of them as an example. So let's select the faces we want to cut. On this toolpath, the side of the cutter always cuts the selected surface, so we're using the side of the cutter. Let's select this one and press OK. And the floor surfaces, we can select our floor. So you put a tick against it and tell Mastercam what's your floor. Okay. Let's leave those settings as they are at the moment, just so I can show you different methods of selecting or geometry things for your toolpath. You see now the cutter doesn't cut the way we want. Okay, so we're going to change it. So to fix it, we want to change the strategy, advanced control for the tooling. So let's change from automatic to, for example, the shortest distance. So we'll always pick the shortest distance between the top edge and the bottom edge of our surface. And let's see the result. You can see now it cuts the way we want. The other way you can drive your tool, if you don't have a floor, for example, you have a side of some 3D model that doesn't have a floor, you can select your guide curves. So the upper rail is the top of the surface, the top of your faces that you want to cut, and the lower rail is the bottom. And you can sync between the upper and lower curve or keep the shortest distance. But so we have the result the same. If you keep, for example, you synchronize between with the upper and lower curve. If you don't have, for example, your face is changing the size, you can't get the proper toolpath. You can synchronize between upper and lower curve, but you need to remember to start both in the same at the same point, if you know what I mean, going to the same direction and on the same height or on the same length. The other way you can do it is by tilt lines. So let's create a tilt line for a sec. We're going to wireframe, line closest between that, and this is our tilt line. Okay, we will use this line as a tilt line. So we don't want the guide curves. Now it's turned off, so we need to select our tilt lines, and it's enough to have one. So let's select the one tilt line we have here. Okay, so in this situation we have our Swarf surfaces and the tilt lines. Let's see our toolpath. See, still the same. So we have many variants how we can select our features to be machined. Okay. Okay, so we have our floor surfaces, we have our tilt lines and everything. We have everything we wanted. What I want to do is add multi-cuts. So I want to cut, you can select by the distance, or so big the distance between the cuts or the number of slices. I know that I want to cut it in, let's say, 3 cuts. Pattern, it will morph from the top to the bottom. In our case it's the same. Or you can step from the top shape. So if you have a different shape on top than on the bottom, it will keep the toolpath shape as the top or as the bottom. I'm going to morph it, so it will be the same toolpath along. Same shape, and we leave as it is. Okay, let's change that to shortest distance and we're good to go. Let's have a look. Our toolpath is ready. Maybe I could do it with 5. Nice. Okay. Okay, we don't need this length, so I'm going to remove it. And now we can select our rotary toolpath. So now our next toolpath, we are going to copy this one. Copy. And paste it underneath. And we're going to change some parameters. So now we want Axial Cut. And we're going to leave stock on the 2 mil. You go zigzag. And the 2 axis control. We have now activated the Axial Cut Settings. So the first one is the increment between your each cut. So how many degree it will rotate the part. So as we are roughing it, I'm going to set it as 36. So we do it 36 cuts. And start angle as 0. You want to start at 0. In our case, it's not really important one. We are roughing the part. And the sweep angle, we are going to machine the full 360 degree around the part. Okay, and the collision control, I'm going to leave on the check surfaces on the 2 mil as well to match. And I'm going to change that to 15 and do not retract. All good. Yes, I know. So check surfaces and drive has the same value. Okay. So this is the difference between axial and rotary. So we have here rotary cuts, and on this one we have our axial cuts. This is how it looks at the moment, our roughed out part. Along the curve toolpath, I need a lead geometry. So I'm going to create one. I'm going to add another op. Okay, another level, and I'm going to create a line going from to the center, from the center of that to the center of that. Okay. Oh, sorry. Again, from the center of that to the center of that. Okay. This is a select Mastercam Multiaxis, and we are going to use along the curve, which is this one. The tool we want to use is 4 or 5 mil ball mill. Let's go 5. Just let me change 4,000. And holder. Use this. And we are going to use this one. $50 mil stick out length, and cut pattern lead is this line. So to select it, you need to be on the wireframe. Okay. So this is our lead. Okay. And the dry surfaces, I just want that, and that. Okay. And selection. So these are the surfaces on the base, on the floor, the whole floor. Okay, at the moment we're going to leave that as it is. 2-axis control, going to leave that as it is. Collision control, I just want to add 2 levels. Oh, sorry, 1 level with tilt tool, and change that to automatic. And I'm going to add some check surfaces. So I'm going to add those bits. And you know what? I've got the cap. I don't want the tool to plunge through any of these holes. That will be my surfaces, check surfaces. Okay. Linking we leave as it is, roughing. Okay, let's see our toolpath. Okay. And we are going to change the step over. I want maybe 0.3. Okay. This good should give us nice finish. Nice. okay, nothing is plunging anywhere. We'll see on the final simulation. Next step, we are going to finish those spigots, okay? So let's do it from the bottom one, Alt 3. This is the back view. I need to create some additional geometry for this one. And I will create on the 2D, and I want to click on the 0 here, right click on the window with the dimension and the Z coordinate of the point, and I want to select the top. So now I am working on the level on the C plane, back 2D on 46mm depth. So I'm going to wireframe, and I want these two. So the wireframe, it draw the lines on the Z46. Okay, so I'm going to use these two chains to finish the wall and this radius here. So I want this toolpath to clean up a little bit around, so I'll make it slightly bigger, and I'm going to select that, so this chain around, okay, and I'm going to offset it in outside direction, but I will offset it maybe to middle. Okay, and I'm going to move it. I don't want to have too much, too many bits. Okay, so this is my geometry. And the next toolpath I'm going to use is in milling, but we'll select in different way because I don't want to use this one as it is high speed. I want to use I don't want to use this blend as this high speed. What I'm going to do, I'm going to right click here, milling toolpaths, and I'm going to surface finish toolpath and select blend. Okay, so now we need to select the faces we want to blend, our drive surfaces. I want to activate my cups, so I'm going to do this and part of that, okay, and maybe part of that. All right, and the check surface is going to be that. Now, I'm not going to select any check surfaces at the moment, but I need blend. So our blend surface is going to be, let's say that, to that. Okay, Okay, so we're going to add some speeds and feeds, and we are going to select something smaller. I want to use maybe a 3mm ball nose. Why the hell so long? Whoa. 35 or 30, 60. Okay. Whoa. Yeah. And with this one, we are going to go to surfaces, parameters. That looks all good. And here, step over. Let's start it with. Let's see what we get first, instead of going very tight and then wait a long time for our toolpath to generate. So let's go that way. Okay, let's see what's going on. I'm going to reselect all of those. So let's start again. One surface, second surface, okay, okay. And I'm going to reselect my drive surface. Okay. Let's see again. I'm going to just double check my blend surface. Plane. Start back. That looks okay. Oh, did it now? That looks nice. I'm happy with this, so I'm going to change my step over to, let's say, 0.2. Okay. This is how it looks like. That's okay. So as you see, our toolpath, we limit our toolpath between two chains. Between that and that, everything between those two is being chained. And the 3D. Okay. Next. And in this toolpath, of course, if you want, you can use any size of the ball end mill, or even the 6mm bull nose cutter with a 2mm rad, and it will generate the toolpath as well. Let's have a look. The toolpath looks okay. We will run the simulation later. Now let's change the view to the back. In our next step, we will prepare some wireframe geometry for our 2D toolpath. I'm going to use curve one edge function and create geometry on the inner edge of the fillet on top of the spigot. I will use this curve to program my 2D toolpaths, facing and pocketing. As those are 2D toolpaths, I'm not going to go into details. I'm just going to slide through the settings so you can see if you need them. First of the toolpaths is facing that I programmed. So this is the toolpath. This is the chain I selected for this. And tool I used 12mm, this holder, and zigzag method, incremental depth 0, and on the plane tab remember to keep the tool plane and construction plane set to back. This is the toolpath to pocket the inside of the spigot using same tool, standard pocket, parallel spiral, finishing point 2, lead in, lead out, set as here. Depth cuts, set the linking parameters as on this page here. And planes, again tool plane and construction plane set to back. And in geometry you can see the chain I used to produce the toolpath. Okay, in our next step we are going to finish this boss here. As you see, it's on slightly off radially that way, and also is a bit bent. So to do this we need to tell Mastercam actually where it is. So we're going to create a plane. Let's do this. We're going to plane manager and add new, just open the arrow down and select dynamic. Going to click on the face, anywhere on the face, and press move to origin. Okay, and let's call it angle spigot. Click OK, and this is our new plane. So let's select this plane. Of course, work coordinate system will have to stay on top, but we are working on this plane here. I'm going to skip through the next steps. I'm going to create 3 operations. I'll show you the result. Just to finish inside the spigot, face it, and use a blend toolpath to finish outside shape. The settings are exactly the same as for the other spigot. You just need to change the construction plane and tool plane to angled spigot. So we have now that finished inside and outside, that finish inside outside. What we haven't got the finish yet here is this slot around, and we need to finish this guy here. For this one I'm going to use Multiaxis toolpath, so we're going to use a Morph toolpath. Okay, let's do it. Because I've got the undercut here underneath, I will have to use a lollipop cutter, and I'm going to drive my tool towards one point. So we will create a point first. Okay, so let's go to levels and make guide level active, so everything we create it goes to that level. So now we have to create a point. Remember to be on the 3D mode, and we have our level width guide active, tick in front of it. We go into wireframe, point position, and select the top edge. And now we have to transform the position of this point from the top. I'm going to move it down millimeters. So 20 millimeters from the top. Okay. Now we can create our Morph Toolpath. So we're going to Multiaxis, Morph. I have in my hand a lollipop cutter that I don't have in my library, so I'm going to quickly create it. A lollipop cutter. And holder. We are going to use HSK 11. Okay. Sorry. Okay. So curve. We are going from using a solid selection, going from this, that. Okay. Oh, sorry. We are going from this to that. And as our drive surfaces, we are going to select all faces between our curves that we just selected from and to. Don't want to leave any stock, and the cutting method we are going to go one way. As tool axis control, we're going to select to a point, and we're going to select the point we created 20 mm down from the top face. That means from every position on the drive surface during the cut, the tool will point towards this point. Okay, the toolpath looks okay. Let's now go back to our settings and we change our step over to get better finish. So go to cut parameters and the step over, just put 0.1. 0.1 will give us nice finish. And regender to operation. And let's see the toolpath. Okay, nice. Okay. Okay, our next toolpath is going to be a Swarf multi-axis toolpath, and this toolpath will use side of the tool to cut selected drive surfaces. So let's make active our level width guides just to create additional geometry for tool control, and we are going to create lines which we are going to use to control our tool axle, tool tilt during the cut. In our case, I'm going to use the edges between the surfaces. Let's select this guy. Oh, I pressed that multiple times, so I'll have to delete that. This guy, and this edge, and this edge of the surface. That looks good. I'm going to remove few lines. Go to home, delete duplicates. You see 2 lines have been deleted. Okay, after creating our tool axis control lines, we can go and start our multi-axis toolpath. Okay, we can now select our next toolpath. Select Swarf milling from the pattern part of multi-axis toolpaths. In the tool page, we are going to select our tool. I want to use end mill, flat end mill, 1 mm diameter, and adjust your feeds and speeds. Our next setting page is cut pattern, and we are going to select our Swarf surfaces. Click on the face while you're holding down the shift to select tangent faces. In our case, we unticked floor surfaces as we haven't got any, and we're going to select our guide curves, upper rail and lower rail. And as our upper rail, we are going to select the top edge of the slot. When you select the lower rail, try to start at the same, like a tool position, and select in the same direction as the upper rail. Now we're going to select the lower rail, so it's the lower edge of our slot. Go all around. So my lower edge start point is in line with the upper edge. It goes the same direction and finish in the same line as the upper edge. Let's change the advanced control to automatic. That will make our two lines that will activate our two line selection. Okay, tilt lines, and we're going to select our lines that we created on between the edges of our drive surface. Our next setting page is tool axis control, and we're going to change the output mode into 5 axis. And without changing any further settings, let's see how our toolpath looks like. Press OK. Now I can do my fine tuning to my toolpath. I'm going to first change the guide tool to upper curve. So, yeah. Okay, and I want only 3 depth cuts, so I want to cut in 3 slices. So I'm going to multi-cuts, and in pattern slices I'm going to change the number of slices to 3. Also, I'm going to extend the start and finish of the toolpath, so do it in extensions. Extension length at start and length at end. You can change your side, but we keep it auto detect, and orientation we're gonna leave to tool plane. Okay, let's see the result. Nice. This is what we needed. I'll show you how it looks like. Let's go to verify or backplot maybe, and let's see. So this is our first slice, our first depth. Okay, and then we go second one, and the last cut. Okay, all looks good. Okay, now it's time for our last toolpath, and we are going to use Multiaxis Rotary toolpath, and we are going to finish the big diameter in the back, the outside diameter. So select milling and application, select Rotary, select your tool. I'm going to use 5mm ball, set your feeds and speeds, and let's select our cut pattern. So surface is going to be the large diameter. I'm going to select with fillets. Okay, and the cutting method, we want a rotary cut. After that, we can select our step over in the tool axis control, and my maximum step is going to be 0.3mm. Our next setting page is collision control. I'm going to select my check surfaces, the front and the back of that big diameter, large diameter, and I'm going to change stop to leaf to 0.01. Let's see our toolpath. Great, all looks good. So this is our whole part now programmed, except those holes and countersink in the face, but I'm sure you can guys do it yourself. Okay, thank you guys for watching the video. If you found this tutorial useful and you liked the video, please hit the like button and subscribe for future tutorials. Also, don't forget to download your 3D models. You can find the link in the description, and practice. See you soon.